Hi, Chinthaka.
Hi, Boby.
So, very nice photographs. These sensors, what will they do? I mean, they are sensing magnetic field, but magnetic field of...
So, in space, so one thing that the students should not confuse is that we are not talking about the Earth's DC magnetic field.
Okay.
Right. So, if you talk about space, right, there are a lot of different applications like there are low frequency electromagnetic waves.
Okay.
Right, in space.
So, it's a change in magnetic.
Change in magnetic field, right, which is why search coils can be used to detect that. You also have something called radiation belts, where there are a lot of electrons and protons kind of trapped in magnetic fields. So to detect the change in the magnetic field due to these trapped particles in space, again, you need some sort of a magnetic sensor. Also, you have the magnetosphere, but the magnetosphere also has certain dynamics that also have low frequency components.
Okay.
Right. So
this is actually to study
to study the change in
magnetic field itself.
Yeah, just by a coil.
Yeah.
Right. Yeah. But in fact, again, if you look at these pictures, you might think they're just winding coils, but a lot of research actually goes into all the things that we studied before.
Yes.
Before you can use them in space, right? And as we talked about before, there are 3-axis magnetometers in most of the missions. They use 3-axis magnetometers, and also they come in different shapes and sizes.
Yeah.
Right. So here you see something quite small. Here you see a large coil here.
Yeah. Okay. So this looks to me for some kind of scientific research.
Yes.
Space.
Yes.
But the search coil may have many various other applications.
Oh, yes. So this is probably a very niche application. And probably, thinking about it, probably the only time a search coil is just a search coil is used to detect the magnetic fields. No, so there are some other applications. And I think you will realize in the next slide, not this slide, the next slide.
Okay.
You will see what these other applications are, and you'll be able to recognize, I think, when you see the actual instrument.
Okay.
Right. But
try.
Yeah. But before this, Boby, I think if you look at these pictures, what do you see, Boby? You see a couple of coils. But why do you think the coils are kind of
they are in the? I mean, you are talking
connected
about,
in this way. Yeah.
So
what about A? Why? What's happening here? We have two coils. One is going around here, but then the other one is going around here in opposite directions.
Okay.
And then you obviously have the.
So this is for generating field or to measure field?
Measure. Measure. All three designs are for measure the magnetic field.
So for me, it looks like these two coils are competing each other.
Yes, exactly.
Wanted to prove who got more.
Yes, and they are wound in different directions.
Yeah.
Right.
So they both get same induced voltage. The output will be nothing.
Yes.
Zero.
Exactly. That's the whole point of connecting something like this. In opposite directions, is that if you are measuring the same magnetic field, right? Let's say you are measuring the Earth's magnetic field.
Yeah.
But that is not.
And you wanted to measure the
something
change
smaller
alone.
Change alone, for example, right? So here you are measuring the Earth's magnetic field, but that's not what you want to measure. So by doing this, you can cancel that Earth's magnetic field, right? And then if you move one coil closer to the actual field that you want to measure, you get a difference here in the voltage.
Okay. So this is one way it is removing the common mode.
Yes. Yes.
There is some large magnetic field present there. You are not interested to measure that. You are interested to measure the difference alone.
Yes. In this case, you probably have two coils like this. And this is not the only way. You can also have it in a planar arrangement. Again, wound in opposite directions. And one will probably then be exposed to some small field here. Small b, maybe.
Yeah, so in that one, it seems the one is sensitive to field going in the upward direction, other one field going in the downward direction? Is it like that?
This one.
Huh?
Yes. Because it's planar direction.
Correct. Yes.
But here it's the same.
Yes. Difference vertically.
Yes. What about here? It's a little bit different.
Yeah.
But similar to this one.
It's a different design.
Different design.
Because the top coil has got more area.
And this one has more turns.
More turns.
So why do you think you would use something like this?
Maybe the top one is it depends on the application. Maybe in the application, the field change is available only in some specific area.
Yes, exactly. If let's say you want to measure the field from a small source, right?
Yeah.
Then you want this to be quite
exposed
small
to that.
and close to that.
Correct.
In that case, you would make this small, but when you make it small, the problem is you reduce the sensitivity. So what do? You increase the number of turns. And that's what's shown here. Or just different ways of connecting these coils.
Whether this has got some name?
I believe they're called gradiometers.
Yeah. Correct.
Yeah. Kind of looking at the change in the
Yes.
magnetic field.
Yes.
Yeah.